Hello, fourth grade teachers. Today we are going to look at Unit 4C, Investigating Measurement and Data Reasoning. The purpose of this video is to provide an overview of the standards, suggested pacing, and samples of instructional strategies. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 4C. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Unit 4C has one AKS. Under the AKS, you will find the Indicators of Achievement, or IOAs. In Unit 4C, you will teach all of the IOAs for AKS 4MA D6. This standard incorporates problem solving involving intervals of time and metric measurements for liquid volume, distance, and mass. Metric measurements units include weight, grams and kilograms, capacity, milliliters and liters, and length, centimeters, meters, and kilometers. Student-centered learning experiences support building conceptual understanding for this AKS as students engage in the framework for statistical reasoning to ask and answer questions in order to solve problems. When learning this standard, students will solve multi-step problems related to expressing measurements from a larger unit in terms of smaller units and smaller units in terms of larger units. In addition to measurement, students work with fractions by measuring objects to a half, fourth, and eighth of an inch and conduct statistical investigations with this data. Students also learn to ask statistical investigative questions based on things they notice and wonder about everyday situations and collect, display, and analyze data to answer these questions. Students create a plan that determines the appropriate population to survey and how to collect that data. And they have opportunities to determine the difference between representations for categorical data and numerical data presented. Representations for data should include bar graphs, pictographs, and dot plots or line plots. Students should record observations they notice about the shape of the distribution using informal language such as spread out and or grouped. Notice the extension IOA 6D and 6E. Extension IOAs support the differentiated needs for your students. As you can see, the word extension is bolded and in parentheses to notify that these are extensions and are specific to Gwinnett County. Please note you will not find resources from the state of Georgia for these IOAs. As a reminder, the state coding is listed with each GCPS IOA, so you can find resources on the Georgia DOE website. For IOA 6A, metric measurement systems are introduced and include units of mass, grams and kilograms, capacity, milliliters and liters, and length, centimeters, meters, and kilometers. Students express larger units in terms of smaller units and smaller units in terms of larger units within the same measurement system, reinforcing students' understanding of place value. Students reason about the relative sizes of measurement units within the metric system and accurately record measurement equivalents in a 2-column table in the context of real-world problems. Students represent measurement quantities such as time using number line diagrams that feature a measurement scale and develop benchmarks and mental images about units of measure. For example, a meter is about the height of a tall chair and a kilometer is about the length of 10 football fields. Students explain measurement equivalents conceptually without being expected to use decimal notation or multiply and divide fractions. For IOA 6B, fourth grade students engage in the statistical problem-solving process to make sense of number and quantity through graphical displays of data relevant to everyday life. Students generate and make sense of statistical investigation questions based on things they notice and wonder about in everyday situations. Based on the statistical investigative question, students should create a plan that determines the appropriate population to survey and how to collect that data. Students determine the difference between representations for categorical data and numerical data presented. Representations for data should include bar graphs, pictographs, and dot plots or line plots. Students record observations they notice about the shape of the distribution using informal language such as spread out and or grouped. Students ask and answer relevant statistical questions, gather information through observation, surveys, experimentation, and measurement, create graphical displays of data using tables and graphs, and make decisions based on data given and collected. Students use concepts, skills, and prior knowledge and experience from previous grade levels to draw scaled picture graphs and bar graphs. Note, numerical data is a type of data expressed in numbers rather than natural language descriptions. This is sometimes called quantitative data. To engage students meaningfully in learning and doing statistics, students should be involved in the full process from asking and defining questions to interpreting results. This broad approach provides a framework and purpose under which students learn a variety of ways to collect data, create graphs, and analyze data. For IOA 6C, this IOA provides a context for students to work with fractions by measuring objects to a half, quarter, and eighth of an inch. Students create a line or dot plot of this data collected to display distribution. Students analyze the data set and notice trends or the shape of the data, a sense of how data are spread out or graphed, grouped or clustered, what characteristics about the data set as a whole can be described, and what the data tells us in a global way about the population from which they are taken. Note, the Georgia DOE uses the term line plot and dot plot interchangeably. Students need an exposure to data plotted using a line plot with X's and dot plots using dots. For extension IOAs 6D and 6E, the purpose is for students to use their creativity, critical thinking, problem solving, and reasoning skills to determine their own way to apply the understanding of this AKS through various platforms to show the application of skills and concepts in the real world. For extension IOA 6E, students will solve multi-step problems using the 4 operations when given graphical displays.
In Chapter 2, we will be discussing our Unit 4C pacing. Our pacing guides are closely aligned with the state pacing to ensure we are following the expectations from the state. The pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. The vertical progression shows that prior to 4th grade, students are asking questions and answering them based on gathered information, observations, and appropriate graphical displays to solve problems relevant to everyday life. This also includes bar graphs, pictographs, and dot plots. They're going to use rulers to measure lengths in halves and fourths of an inch and whole inches. They're going to generate measurement data by measuring lengths using rulers marked with halves and fourths of an inch, show the data by making a line plot where the horizontal scale is marked off in appropriate units, whole numbers, halves, and quarters. They're going to estimate and measure liquid volumes, length, and masses using customary units, ounces, pounds, tons, fluid ounces, cups, pints, quarts, gallons, inches, feet, yards, and miles. And they're going to solve relevant problems involving these measurement units. And of course, this is customary in 3rd grade. They're going to tell and write time to the nearest minute, and they're going to estimate time to the nearest 15 minutes from the analysis of an analog clock. They're also going to solve meaningful problems involving elapsed time, including intervals of time to the hour, half hour, and quarter hour, where the times presented are only on the hour, half hour, or quarter hour within AM or PM only. You'll see that when we start to look at what we're doing in 4th grade and what you've already heard about 4th graders, this is a really good vertical progression from what 3rd grade's coming into 4th grade with. After 4th grade, they're going to be solving problems involving customary measurement, metric measurement, and time, and analyze graphical displays of data to answer relevant questions. So they're going to be doing what they did in third and fourth grade in fifth grade. They're going to ask questions and answer them, again, based on gathered information, observations, and appropriate graphical displays to solve problems relevant to everyday life. They're going to explore realistic problems involving different units of measurement, including distance, mass, weight, and volume, and time. And they're going to convert among units within the metric system and then apply these conversions to solve multi-step practical problems. They're going to convert among units within relative size of measurement units within the customary measurement system as well. So let's take a look at our pacing guide. The suggested length of Unit 4C is 4 weeks. Unit 4C focuses on AKS 4MA D6, measure time and objects that exist in the world to solve real-life mathematical problems and analyze graphical displays of data to answer relevant questions. I'm going to scroll on down here. Oops, there we go. You can see that Unit 4C starts with IOA 6C. There's a total of 5 suggested days of IOA 6C, with the last day being clustered with 6B. Or I'm sorry, it's not the last day, but it's one of the days being clustered with 6B. So let's take a look at our pacing for IOA 6C. You can see that the first day of pacing just focuses in on that measurement to the nearest half, fourth, and eighth inch. And remember, vertically, they are coming in from third grade already measuring to the nearest half and fourth inch. So we're adding in that eighth of an inch. So this lesson, that is the focus. Then we're going to be going into creating dot, and you can see dot or line plots to display the measurement data that has been collected. And then we'll be moving into asking questions and answering them based on the graphical displays, which is going to be that analyzing and interpreting the data. I'm going to scroll back up to the top to talk about some other important features of the pacing guide. The suggested instructional sequence is located on the left side of the pacing guide. The left-hand column provides the learning progressions for the AKS IOAs, showing whether it's concrete, representational, or abstract. The bulleted list states specific learning objectives within the IOAs, as well as suggested manipulatives. And then, of course, on the right-hand side, we have all the other resources are showing all the resources, which could be traditional lesson plans, task-based lessons, formative assessments, small group instructional moves, student tasks, and any additional resources that are aligned to the learning targets for that day. Also embedded in the pacing guide is suggested resources to use from our textbook adoption, Georgia Reveal. Georgia Reveal is an adopted resource. However, it is not your main and only resource. You will find Georgia Reveal adapted lessons aligned to the intended learning objectives, as well as other resources on the pacing guide. These are just a few of the Georgia Reveal resources available, the ones on your pacing guide, but please go to your employee portal to access all of the Georgia Reveal resources available to best meet the needs of your students. So now let's continue going through our pacing. So we've already talked through IOA 6C, but I want to scroll down and point out a couple of those things we just talked about. So you can see here, there is a lesson for Georgia Reveal. This is from Unit 13, Lesson 10, and here's the title of the unit. There's another lesson from Georgia Reveal. I'm looking to see if there's anything from the Georgia DOE. I'm not seeing anything right here, but I'll point those out as we get down to those later on in our pacing guide. But let's stop here at this day. This is a task-based lesson. Notice that we have labeled it differently to indicate it is a task-based learning day, not a teacher-directed lesson. So for this particular day, This is the one where it's clustered 6B and 6C together. We did this so that the students will have an opportunity to engage in task-based learning, to collect measurement data, determine what measurement data they want to collect that measurement data, but then to create a line plot since we're just coming off line plots. They will have that chance to ask and answer questions on this day as well. And right after this task-based day, there's another task-based day suggested. This is only, you can see IOA 6B, where students are going to be engaged in solving problems relevant to everyday life as they explore data collected by the University of Georgia to show the effects of pollinators on our ecosystem. In this task-based lesson, the students will create appropriate displays to display data. So we're not telling them what kinds of ways to display. They will determine that on their own. And they're going to ask questions and answer questions based on the gathered information. As soon as we're finished with instruction for 6B, we suggested moving into IOA 6A. There is 11 suggested days for IOA 6A. We begin 6A with instruction on relative size of metric units. And then we progress to finding metric measurement equivalents using two-column tables to solve problems involving units of measure. After metric measurements, we move into elapsed time, solving to the nearest minute. So let's kind of scroll through this and talk through some of this. You can see on this very first day, we are doing the relative size of metric liquid volume. Then we're going to be talking about the relative size of metric mass and using those balance scales for mass, using the liter and milliliter containers so students really get a good understanding of relative size. Then we're also going to be moving into finding those equivalencies where they need to find equivalencies with the metric units of measurement. And then moving into solving problems involving metric units of measurement. And I need to point out a Georgia DOE test. Let me go back and try to find one of those. I'm still, still seeing Georgia Reveal. I'll keep looking for that. We'll come back to that in just a moment. After talking about metric units, we're going to be moving into time. So let me scroll down to that. Okay, here we go. So right here is our first day for, it's still IOA 6A, but we're switching gears and talking about time. You can see that we have suggested some different, like talking about end time unknown at first, then moving into change of time unknown, and then lastly, start time unknown. That is just the suggested pace for that. Okay, so here I'm noticing that we do have one of those Georgia DOE tasks on there, so I want to talk to you about that. When you see a Georgia DOE task on pacing, when you click on the actual task, it opens up to a large document that has many tasks and resources, but you can see we have labeled the actual page for the specific task. So for this one, Myra's bus dilemma, when you click on this link, it should take you to page 4, which is the first page of this particular task. Similar to your GCPS resources, the Georgia DOE resources are live documents that could be updated at any time by the state. So that is one reason we did not make these into PDFs. That's why they are live links. You can see that towards the end of IOA 6A, we have another task-based learning day. And lastly, we have a suggested Unit 4C summative assessment. In Chapter 3, this portion of the video will sample specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, sometimes referred to as the ATS, for guidance on additional instructional strategies for each IOA. In mathematics, the emphasis is on reasoning and thinking about the quantities within mathematical context. Specific strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that they are most comfortable with and that make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. To build conceptual understanding of solving a measurement word problem for IOA 6A, I'm going to show you how to use concrete materials that will have students see the relative size of the units as well as solve the problem. So let's look at this problem. Susan bought 2 meters of fabric. She needs 160 centimeters of fabric to make her dress. Does Susan have enough fabric to make her dress? Justify your thinking. All right, so here's some things that we know. We know that Susan has 2 meters of fabric. That's how much she has. And then we know from the problem that she needs 160 centimeters of fabric to make a dress. And so we're trying to solve for, does she have enough fabric? And we're going to justify that using our concrete materials. So what I have are 2 meter sticks. This is 1 meter and this is 2 meters. So these 2 meter sticks are going to represent the amount of fabric that Susan has. And we're going to use base 10 blocks, the rods in base 10 blocks, to help us solve for if 160 centimeters of fabric, if she has enough to have 160 centimeters of fabric. If this was not a multiple of 10, then I could use the rods as well as some of the units of the base 10 blocks. But this base 10 block is equivalent to 10 centimeters. So I'm going to place that up on above my meter stick. So this is 10 centimeters. We're going to keep going until we get to 160 centimeters to see if she has enough fabric. So now we have 20 centimeters, 30 centimeters, 40, 50, 60, 70, 80, 90, 100. So I have shown right here one equivalency. I see that 1 meter is equivalent to 100 centimeters. But again, I'm trying to see if she has enough to have 160 centimeters of fabric. So here's our 100. I'm going to go down to the second meter stick and skip counting by tens. 110, 120, 130, 140, 150, 160. So now we have proven that if Susan has 2 meters of fabric represented by our 2 meter sticks, and if she needs 160 centimeters of fabric to make her dress, that she has enough. I can even see that she has plenty because she would have actually 40 centimeters too much, or 40 centimeters left over, because it would take 40 more centimeters to make 2 meters. So using our concrete materials, this is a great way to help students see the relative size of units as well as solve problems with units. Then we would transition them into solving this with two-column tables. We are going to look at a concrete instructional strategy for IOA 6A, solving for an elapsed time problem. We have some manipulatives called time in your time interval kit. You have bars that show 1 hour, 30 minutes, 15 minutes, 10 minutes, and 5 minutes. And also on the other side, it shows you the fraction amount of time. So we're going to use these today to assist us in finding out an elapsed time problem. Let's go ahead and look at the problem. When Sarah wakes up in the morning, it takes her 45 minutes to get ready for school, and then she rides the bus for 25 minutes. If school starts at 8:15 a.m., what time does Sarah need to wake up? Well, there's several things going on in this problem. I know the time that school starts. I also know the amount of time basically she needs before she gets to school. She needs 45 minutes to get ready, and she has to ride the bus for 25 minutes. I'm trying to solve for the time that Sarah needs to wake up. I like to use an open number line as a tool to help me solve for an elapsed time problem. So I'm just going to use this as a straight edge to help me draw my open number line. And then again, we're going to use our time interval kit bars to help us as well. So here's my open number line. This is going to help me keep track of everything to solve the problem. I'm going to think about the things that I know. Let's see. I know it takes her 45 minutes to get ready for school. I know it takes her 25 minutes to ride the bus. And then I also know that that school starts at 8:15. So she's got to be at school by 8:15. This is going to be the end of time. So I'm writing it at the very end of my open number line. So we're going to label that. This is when school starts. Okay, so I know this and I know these two things. So I've used my bars and my time interval kits to make the amount of time for these two things. So I've got my 45 minutes and I've got my 25 minutes. And I'm going to use those. As I subtract out these minutes, I've got to subtract out all of these minutes to figure out what time she needs to wake up. So the other thing that's very important to think about when we are solving elapsed time problems is that 60 minutes, you can see that 60 minutes is equivalent to 1 hour. That's real important to know. Okay, so let's go ahead and get started here. I am seeing this 15 minutes after 8. So I want to go ahead and subtract out those 15 minutes first. So what I'm going to do is I'm going to decompose 45 minutes into 30 minutes and 15 minutes and go ahead and subtract out this chunk of time first. So if I subtract out 15 minutes, then that is going to bring me back to 8 a.m. So I can kind of show that here, 15 minutes. Okay. Then I still have my 30 minutes left from the 45 minutes it takes to get ready for school. So next I'm going to subtract out my 30 minutes. So we will put that about right here. Well, this is where this comes into play. If there's 60 minutes in 1 hour, and I'm at the hour mark of 8 a.m., then I know if I'm going back in time that my hour, if I'm only subtracting out 30 minutes, my hour is going to be 7. And if I know that 60 minus 30 is 30, so I'm at 7:30 a.m. when I do that. So let's go ahead and show that on our number line as well. So there's our 30 minutes. Well, we still have the 25 minutes that it takes to ride the bus. Well, I'm at 7:30 a.m. right now. So I'm just going to go ahead and subtract that whole chunk of time because I know that 30 minus 20 is 10. So 30 minus 25 is going to be 7. It's going to be 5, basically. So 30 minutes minus 25 minutes would be 5 minutes. The hour is still going to be 7. And so we're going to be 7:05 a.m. Let's go ahead and make this hop back as well on our number line. So I've labeled it on my number line and I've used my blocks to help me see that. So now I know that Sarah needs to wake up. What time does Sarah need to wake up? Sarah needs to wake up at 7:05 a.m. Because if she wakes up at 7:05 a.m. and it takes her 25 minutes to ride the bus, that could bring us to 7. Well, we did the bus afterwards, but basically what I like to do is add all of this time back up going forward. Anytime I'm going backwards, I think it's smart to go forward and see if it all makes sense. So 7:05 a.m. plus 25 minutes will get us to 7:30 a.m. 7:30 plus 30 minutes will get us to 8 a.m. And 8 a.m. plus 15 will get us to when school starts at 8:15 a.m. So we have solved for basically the start time here. We knew the end time, and we also knew the change of time. Let's look at an instructional strategy for IOA 6A, solving a multi-step metric measurement problem. Nancy is on the track team and ran 3,241 meters on Monday, 2 kilometers on Tuesday, and 2.5 kilometers on Wednesday. Nancy has a goal of running a total of 10 kilometers this week. How many more meters will Nancy need to meet her goal? I'm also given that 1 kilometer equals 1,000 meters. The first thing I am noticing about this problem is that we have meters and kilometers as our units in this problem, and that our answer needs to be in meters. So one of the distances that Nancy ran was 3,241 meters. But then I know that another distance she ran is 2 kilometers, and another distance she ran is 2.5 kilometers. So since my answer needs to be in meters, I'm going to draw a 2-column table to help me to show the equivalencies, basically, to figure out how many meters are in 2 kilometers and how many meters are in 2.5 kilometers. But then I also need to know how many meters are in 10 kilometers. So let me start by drawing my 2-column table. And I'm going to put kilometers on the left-hand side and meters on the right-hand side. So now I'm going to fill in for what I know. I know that 1 kilometer is 1,000 meters because that was what was given to me in my problem. I also noticed that there is a fraction, 1/2 kilometers in one of my distances. So I need to know how many meters are in half of a kilometer. So if 1 kilometer is 1,000 meters, then half of 1,000 is 500. So a half of a kilometer is 500 meters. I am going to take my equivalency table out to 10 kilometers. Since I know that's the highest, I'm going to need to find out. So I'm just going to keep filling out my chart. 5 kilometers is 5,000 meters. And then 6 kilometers is 6,000, 7 kilometers is 7,000. Gonna keep going until I reach 10,000. So now I should have all the information that I need on my 2-column table to help me solve the problem. Now, the next thing I'm noticing about this problem is there's a lot going on. There's many steps. So I like to create a bar model to kind of help me visualize what's happening in the problem. So the first step is just to figure out what is the distance she's already run. Like, I know her goal is to run a total of 10 kilometers per week. That's her goal. But how far has she already run? So she's ran 3,241 meters on Monday. I'll just put an M for Monday to kind of keep track. Then I'm going to add to that 2 kilometers. Well, my answer needs to be in meters, remember. So I'm going to come over to my 2-column table, my equivalency table, and I see that 2 kilometers is the same as 2,000 meters. So let's write that in. And that is what she did on Tuesday. Then she ran 2.5 kilometers on Wednesday. I'm going to have to add that to that. So say 2 kilometers is 2,000. A half of a kilometer is 500. So when I add those together, I get 2,500. 2,500 meters on Wednesday. So this is kind of a visual of what has happened so far. I need to find the total of that, like estimating. I could think of this as kind of like 3,000 plus 2,000 plus maybe 3,000 if I round that up. So 3,000 plus 2,000 is 5,000. And then another 3,000, even if I round up, would only get me to 8,000. So I know she's run, I'm going to estimate she has run less than 10 kilometers, which is the same as 10,000 meters down here. So let's go ahead and add these up. Oh, and you know what? These two I can add up mentally in my head. I know that 2,000 more than 2,500 is going to be 4,500. So that will save me a step with my addition there. I can do that mentally. So 4,500 plus 3,241. So I'm going to go to my ones place and add up my ones, then my tens, then my hundreds. Notice there's no regrouping. So the total amount she has run so far is 7,741 meters. Okay, which I know is less than 10 kilometers or 10,000 meters. So let's move on to step 2 now. So for step 2, I'm going to draw another bar model to kind of help me visualize this. So if she has run 7,741 meters so far, and she has a goal of running 10,000, I'm going to draw this bar shorter because 10,000 meters. I'm sorry, so her goal was really 10 kilometers. Let's go back to the problem. But down here, I saw that 10 kilometers was 10,000 meters. So I remember my answer needs to be in meters. So I'm making all the equivalencies for my kilometers into meters. So that's her goal is basically here, right here. And then this is what she's run so far. So what I'm trying to figure out is the difference in those two things. And I'm going to first, like I'm thinking this is what I'm really solving for, right? So there's different ways I can do this. Usually when I'm thinking of a how many more scenario, I know that I can solve that with subtraction because I'm trying to find the difference. So I could think of this as 10,000 minus 7,741. And I'm going to give it a variable. I'm going to make the variable G. So up here, I'll go ahead and make that a G as well. That's the unknown that I'm solving for. It is possible for me to add up from 7,741 also to find the difference. I could say 7,741 plus G equals 10,000. So we want kids to understand that inverse relationship of addition and subtraction as well. They could solve either way. If I'm solving it with addition, probably the best strategy that I can think of is to put it on an open number line. But I want to go ahead and solve it with subtraction today because I want to highlight another strategy for you today with subtraction. So the next thing I would like to do is let's write out this with subtraction. So I'm going to come over here and solve this. So a lot of students have difficulty subtracting across zeros, especially if they're trying to use the standard algorithm, because there's so much regrouping and it just gets very confusing. So we can use a strategy called the compensation strategy, or finding a constant difference. If we subtract the same thing from each part of a subtraction problem or add the same thing to each part of a subtraction problem, we are keeping a constant difference. If a student doesn't understand this, you can show it on a number line. It's a good way to show that. I don't know. Oops, oh, that's kind of cool that I can zoom in and zoom out. Now I've learned something new about this. Okay, so what I'm going to do, especially if it's going across zeros, we can subtract out 1. Let me make that a different color so it kind of stands out. So we can subtract 1 from both of our numbers, and that keeps a constant difference. So our new problem is going to be 9,999. That's 10,000 minus 1. And 7,741 minus 1 is 7,740. And now that I've kept that constant difference and I've subtracted 1 from both, I do not have any regrouping to do. So I can easily subtract 9 ones minus 0 ones is 9. 9 tens minus 4 tens is 5 tens. 9 hundreds minus 7 hundreds is 2 hundreds. And then 9,000 minus 7,000 is 2,000. So now let's take this back to our problem. So her goal was to run a total of 10 kilometers or 10,000 meters. The question is, how many more meters does she need to run? So we were solving for this unknown. So we have found that Nancy needs to run 2,259 meters to meet her goal. And that also, we found that from saying 10,000 minus 7,741 equals 2,259. Show you an instructional strategy for IOA 6C. During recess at school, the width of the leaves that fell to the ground were measured. The measurement of each leaf's width is shown to the nearest half, fourth, and eighth inch. Create a line plot to display the measurement data. Just going to pull that in a little bit. There we go. All right, so one thing I'm noticing when I'm looking at the fractions is that we have different denominators when I'm looking at this data set. I see that some of the leaves measure to the nearest half inch, some leaves were measured to the nearest fourth of an inch, and some leaves were measured to the nearest eighth inch. And that's exactly what it says here in our problem as well. Some students may opt to find equivalent fractions for these and make all of the denominators 8 before they decide to draw their line plot, and that's perfectly fine. What I'm going to show you today is how to draw a line plot with different denominators all on the same line plot, connecting that to how we measure to the nearest half, fourth, and eighth inch. So using those same markings on a line plot that we would be thinking of when we're thinking of measuring with a ruler. So the first thing I want to do is make a kind of a tally chart to help me organize the data. I'm going to do that up here. I know that these leaves, the lengths of the leaves were measured in inches. That's going to be what this side of my tally chart is going to be, the left-hand side. And then I'm just going to put tallies here, which is basically going to tell me the frequency. How many times did that occur? So I know that one of the leaves, or not one, but I know that one of my, I'm just going with the first thing that I see in my data set was 2.5 inches. So now I'm going to see how many times did that occur. So there was 1 leaf, 2 leaves, 3 leaves. So I'm going to put 3 tallies. The next measurement was 2 1/4. I see that 2 times, 2 1/4. Let me put that on my table. Just double check that. Yep. The next measurement I see is 3 inches. And that occurred 1, 2 times. Then I have 2 6/8. That only happened once. 2 3/8 was one of the leaves, and one of the leaves measured 2 7/8. Okay, so this is going to help me when I start to make my line plot. I can just go back quickly up there and see how many X's to show on my line plot for each measurement. Okay, the next thing I need to think through is my starting my line plot to create that line plot now that I have that done. So I'm going to draw an open number line. I know that I need to put a title. So this particular scenario is about the width of leaves that were measured at recess. So I'm just going to simply call it width of leaves. And then I'm going to think about the numbers that I'm going to place on my open number line. When I look back over the data in my tally table here, I see that none of the measurements were below 2 inches. And I see that the largest measurement was 3 inches. So basically, all of these measurements are going to fall basically from 2 to 3 inches. So I don't need anything more than 3 inches, and I don't need anything less than 2 inches. So that is going to be basically the endpoints of my measurements on the number line. And the other thing that's really important here is it should be labeled as well. What do these numbers mean? These numbers are inch measurements. So I'm going to put measured in inches. Whoops. I could just write inches below. That would work as well. Okay, so I told you I was going to kind of connect this to a ruler. So we're going to be putting in our hash marks, kind of thinking through what it would look like on a ruler as well, and starting with our halfway point. So most students, I think, would find the halfway point to be the easiest. So if I'm partitioning this whole entire line between 2 and 3 in half, I'm going to create 2 equal parts. So there's my halfway point. And so when we're measuring, that would be the same thing. It would be directly in between 2 whole inches. If we have 2 inches and 3 inches, then this halfway point would be the 2.5 mark. Then students also measure to the nearest 1/4 inch. I'm going to color code my fourths in red. So I need to have 4 equal parts. So I need 2 equal parts on this side of the halfway point and 2 equal parts on this side of the halfway point. Students have a misconception of counting the actual hash marks, but we're really counting the equal parts. So sometimes it would be beneficial to actually show that, that's what you're counting. Of course, I'm going to erase that because I don't want to keep that there, but those are my 4 equal parts. And now we're going to go in and put in our 1/8 marks. So I will partition each fourth in half. So I have 4 equal parts on this side of the halfway point and 4 equal parts on this side of the halfway point. Now I'm going to go in and start to label so that I can plot. So my first hash mark here is going to be 2 1/8. I'm going to count by eighths, 2 2/8, 2 3/8, 2 4/8, 2 5/8, 2 6/8, 2 7/8. Now I'm going to go in and write in my fourths. Well, because I color coded it, it's very easy to see where those are going to be. Of course, this blue mark is also going to be a fourth because that is this. If this is 2 1/4, then this is 2 2/4. I'm counting by fourths now. And then 2 3/4. And then we're going to go in and put in our half. 2 1/2. So now that we've done that, this is also, I think it's great to see these equivalencies as well. So by doing this, I see that 2 2/8 is at the same location as 2 1/4. Those are equivalent fractions. I see all the ones that are at the same location as 2 1/2, 2 4/8, 2 2/4, and 2 1/2. They're all equivalent. And then 2 6/8 and 2 3/4 are equivalent as well. Okay, so now that we've done that, we are ready to start plotting our x's to create our line plot. So before I get started with that, just want to say that a line plot is where you are using x's to plot your data points, and a dot plot is where you are using dots. So first I'm going to show it with a line plot, and then I'll kind of make that connection to the dot plot. The Georgia DOE used dot plots. I kind of use them interchangeably, but that's really the only difference, is using an X versus a dot. So let's go ahead and start this. So we need 3. So there were 3 leaves that measured 2 1/2. I see that up here. 3 that measured 2 1/2. So I'm going to put 3 X's above 2 1/2. And then there were 2 leaves that measured 2 1/4. There were 2 leaves that measured 3 inches. There was 1 leaf that measured 2 6/8 inches. 1 leaf that measured 2 3/8 inches, and 1 leaf that measured 2 7/8 inches. So we have followed our directions. We have put in our title. We've created our line plot, plotted all of the points on it. And now we could go in and answer some questions about the data. We can draw conclusions about the width of leaves. I don't know if it would tell us the kind of tree it was unless we know a lot about the width of leaves, but we can find out, we can think about what these things mean, like interpreting this line plot. Like I know that every X was a leaf. So if someone asked me how many leaves were measured that day, I could literally count the X's. If someone wanted to know what the difference in the greatest width of the leaf and the least width of the leaf, then I could see that 3 inches was the greatest measurement taken, and 2 2/8 or 2 1/4 was the least measurement taken, and I could subtract to find the difference and so forth. Okay, going back to the dot plot. So the only difference in a dot plot and a line plot is how you're recording that. So if I was going to make this a dot plot, basically all of these X's would just be dots like this. I would still want my dots to be the same size. I would still want to, make sure that my data was displayed correctly. But that's what it would look like.